Alright, so before I do this next time lapse, I just want to quickly talk through the code. Now, as you saw in the previous time lapse, the issue was that we're giving each thread a fixed amount of space to render, but one thread may be faster than the others. What we really want that thread to do is once it finishes rendering its space, to jump into another space and start rendering it. Which, it's a little tricky, but actually there's a quick fix. The quick fix is instead of giving each thread some space, we just give each thread the whole space, but we put a mutex on every scan line. So before a thread goes to render a line, it checks if that line is available to render, basically, and then just keeps going like that. It's actually surprisingly good. So here's how it goes. We include mutex, and then in the engine, we add an array of arrays, so like a whole bunch of scan lines. I've just got this down to some small numbers for testing right now. So here's how it goes. Where are we? Oh, that's the freeing code. So when we dispatch the threads, we allocate, what are we? We're like 600 high, so we allocate 600 mutexes over here and put them in the unlocked state. And then when we create the worker thread, we put in that whole set of mutexes so that every thread will be able to query for every scan line, is that scan line being rendered? What's up with this? I keep hiccuping. Okay, so when we go to render, our worker thread knows about the scan lines, and here's how it uses them. It goes down through the whole space, and then the first thing it does before it tries to render is it checks, is that scan line available? And what this function does is it's sort of like lock, except when you call lock, you wait for the mutex to become available before you grab it. But this will simply attempt to grab the mutex and then return whether that was successful. So if it returns false, then that thread is either being rendered or has been rendered. So we can just continue on to the next line. And we could unlock it afterwards, but I'm just worried that another thread might try to re-render a thread that's been rendered. So the next step in this will be to learn a little bit more about synchronizing operations between threads. But anyway, that was the overview. Now I will dial these numbers up again, and we'll see how much faster this goes. Okay, so that was pretty good. We were able to shave, I guess, about 20% or so off for performance, which is good, not too dramatic. Now, the other thing is we're doing calculations, and here we have this hit function for the sphere, but on modern CPUs, we have advanced vector extensions, which means the CPU has some registers which aren't just 32 bits, they're not just one float. They can hold a whole bunch of floats. I've attempted to implement some SIMD optimization based on AVX2, so 256 bits or 8 floats. So what I do is I have this whole set of spheres, and I can record their geometric attributes, their X, Y, Z, and radii, and I can process those spheres 8 at a time. So if we go down to this hit function, it's a little bit messy. Basically, what this comes down to is writing assembly code in C++. It's compiler intrinsics. That's what it is. So for instance, if we look at the dot of something with itself, well, we know the dot of something with itself is the sum of all the components squared. So this ray direction x, well, it's really just the direction of the ray. It's just the same number because we're going to test it against 8 spheres. But anyway, we multiply it with itself, and we sum that up with these ones here. Yeah, that's right. So we add this with the sum of these other 2 square components, and it's actually a lot of fun taking this code and rewriting it in intrinsics. But anyway, I'll give this a go. Oh, and the other thing is, because we're processing the spheres 8 at once, I think I found about 16 spheres was ideal. So now each node can hold 128 spheres because that's 16 blocks of 8. So we are processing, we've got larger blocks, we're processing more in one go. So I'll play this out. Thanks for watching and have a good one. Bye.